Students, I am K. L. Janghel, Assistant Professor from Rumta College of Engineering and Technology, Bhilai, Chhattisgarh. So, I am going to deliver the talk now on structural geology. In geology, why do you need geology? Geology means it is the study of, geo means earth, logy means study of. Okay. So, study of earth means what? You can say, sir, we are also studying the earth in geography also. Yes, geography, that is the graphical position on the earth surface. You are only studying about the earth surface, and that is called geography, and that is much different from geology. What is geology? It is also providing you the knowledge to have the inner view of the earth, how the earth has been formed, structurally what is earth. So, I would like to say earth, it is the, those are different origin theories, and one of the most popular theories, it is a part of the sun, it is a mass separated from the sun, the star, the nearest star, and it is orbiting around the sun only. Because of that, okay, gradually it cooled down, and after cooling down it has made earth. Now, because it is spinning, it was molten stage, it was a molten stage and it was spinning like this, the ball spins. So, because of centrifugal force, the earth, the central portion along the equator got widened, and as a result of that, the axial distance, axial diameter of the earth reduced. Okay. So, those have been all discussed in this first slide, what is the mass of the earth, and then okay, what is the distance from the sun and everything. It is just shown you just as a part of introduction to the earth, and you will see the due to spinning, the radius along the equator is more, and the radius along the north and south pole will be less, because of it is little pressed because of centrifugal force, widened the molten rock, and it got depressed from the two sides, north and south side. Okay. And what is the age of the earth? 4.543 billion years. What is billion? See, in English way of expressing the numbers, you know very well, but even then I am just repeating once for a better understanding. 10 to the power 3, that means 1000 is million, that is the 1000. Million means 10 to the power 6, that means after 1 there will be 6 zeros. So, that is called million. And what is billion? 9 zeros, after 1 writing 1 place 9 zeros, that is called 1 billion. Okay. And after that next comes what? Giga. Okay. Giga means 10 to the power 12, after 1 12 zeros. Okay. So, that is giga anyhow. So, this is 4.53 billion years. Next, this is the earth structure shown, the center part which is more like a glowing rock, etc., yellowish part is the mantle, it is the core of the earth, it is the core of the earth. Reddish part is the mantle of the earth, and the topmost bluish part on the shown, that you can see very thin layer of that crust is there, that is called crust, which is really tough, and that is extending say up to 15 kilometers, not more than that. Okay, 18 kilometers maximum, whereas the earth radius is more than 4000 meters, that means 4000 kilometers. Okay. Earth radius is 4000 kilometers, and the crust is only getting formed with topmost layer of 18 kilometers to 20 kilometers, not more than that. After that you will be finding lithosphere is there, then after that asthenosphere is there, then you will find the then lowermost semi plastic material, more it is going towards the center, the rock becomes semi molten. okay, the reddish part is more molten, okay, rather it is semi liquid. The brownish portion shown beyond the red zone is it is a plastic material. After that, the reddish part may be semi molten, and the innermost core is the completely fluid, complete liquid form, like you must have seen in TV, the volcano when it bursts, when volcano explodes, the lava is flowing. So, that is a sort of molten fluid kind of thing, which is molten rock. So, that kind of rock is there at the core, even more than that, the 5000 degree centigrade temperature is there at the center. Next, this is the again layers of earth described, asthenosphere how much, mantle how much, crust how much, lithosphere how much, everything is described here. Okay. This is also just same diagram, but here it is coupled with the temperatures. You can see on the top what is the temperature, topmost portion is 0 degree. Obviously, when you go to top of the mountain, where Himalaya, there will be a level coming where the temperature is 0 degree. After that above you go, the temperature goes as low as to minus 40 degree also, okay, because of height. So, I am concerned with 0 degree temperature level. I am not concerned above that. I mean to say minus 40. I do not want to go to the height where the temperature is minus 40 degree, like in your Siachen glacier in India, okay, in the northernmost part, which always is in news because of dispute between Pakistan and India, okay, Siachen glacier. So, there the temperature is minus 42 degree. I am not concerned with that to explain here. I am definitely concerned so far nationality is concerned, but here for explanation purpose I am only concerned from where the 0 degree and greater temperature starts downward, from that height I am concerned. So, you can see how the upper mantle part is, on the topmost blackish part is the earth crust, including lithosphere and those kind of things, okay, asthenosphere etc. And then starts upper mantle, then transition etc. Okay. Then comes lower mantle, then comes D layer where the temperature, it is shown temperature also, see it is all in Celsius, centigrade 680 degree, 2700 degree, okay, 2900 degree, these are all Celsius. Now, the earth pressure also starts working. What is that? 125 GPa at 22 degree centigrade, 22,100 degree centigrade. Okay. So, it is, see the 1 GPa is how much? It is 10 it is 10 to the power 4 bar. That means, what is 10 to the power 4? That means, after 1 4 zeros, that means it is the pressure is 10,000 times more than 1 atmospheric pressure. 1 bar is 1 atmospheric pressure. Okay. What you have read in physics, 760 mg of 760 mm of mercury column in the physics, okay, in your school time. So, whatever is 1 atmospheric pressure, to that 10,000 time is 1 GPa, that much of pressure is there. Outer zone, how much? Outer zone of mantle rather, it is how much? See 5100 degree centigrade. Okay. How much pressure? 330 GPa. Okay. Then bottommost center portion, earth center, it is how much? See, it is shown only the temperature with 5500 degree centigrade. So, this is the thermal gradient shown. Next, it is a thermal gradient line, again explained through the graph, how it is going down and increasing, and along with the increasing pressure in GPa etc. whatever. Here the temperature is in Kelvin. 1 Kelvin is how much? 1 Kelvin is how much? You must have read minus 273 degree centigrade is forming 0 degree Kelvin, is it not in your physics. So, it is based on that. Maximum depth of drilling was done up to 12 kilometers in Russia western zone in the year 1994. It took 24 years, that is the just for general knowledge I have added this. So, that you can understand that how difficult it is to go for drilling, and that too up to 12 kilometers, that means around 70% of the earth crust has been covered in this drilling. Next, 70% of the earth crust has been covered. Elements are in earth crust, how much it is? See, oxygen 46.6%, in what form? Forget about the air which is having oxygen, it is the oxygen in earth crust. How? It is in the form of oxides. None of the ore is available except the gold and diamond. None of the ore is available in its pure form. Everything is in converted form either to oxide or to sulphide or to carbonates. So, these are the basic forms of the earth, of the minerals, or the what is mineral? In fact, every rock is formed of more than single mineral. Okay? There are rock forming minerals. So, those minerals are different than the minerals which are commercially important. Anyhow, we will come to that later, or it will be taught by some other faculty maybe to you. So far geology is concerned, there are different types of rock forming minerals and different types of commercial minerals. Okay. Anyhow, so oxygen is in the form of oxide from, see, though the like iron oxide Fe2O3, okay. Fe2O3 is hematite, it is iron ore, but it is oxide of iron. Similarly, magnetite, which is having magnetic property also, though it is ore, but it can be, its particle can be attracted by the magnet, because it is purer form of iron ore. More of iron is there, Fe is there. Okay. So, see, in case of hematite, the maximum it may go up to 71%, whereas in case of magnetite it may go up to 73%, 73.6% or something. So, it is more purer form chemically also, and that is also written as Fe3O4. The magnetite is symbolized by Fe3O4, ferric oxide, and but here the also oxygen is added. I mean to say that how? From where it has taken the oxygen? It has taken the oxygen from atmosphere only, while weathering agents have worked on it. Similarly, silicon is 27.7. Now, why silicon has come so high? Why silicon has come so high? See, in the igneous rock, in the earth crust or in formation of igneous rock, you will find that silica is the largest contributor. Silica you will find in the form of quartz, silica you will find in the form of quartzite, silica you will find in the form of even micaceous ore. Mica is also basically silica. Similarly, aluminum is also in the form of, it is nothing in free state. Silica is there, SiO2 is there, pure silicon you will find nowhere. It is again combined with oxygen, SiO2. So, oxygen is there maximum 46.6. Aluminum oxide, there will be aluminum oxide in Koraput, aluminum oxide is there, Al2O3. Similarly, iron, as I said, Fe2O3, Fe3O4, calcium 3.6 only, but it is never in the free state. It is formed in the form of calcium sulphate, where CaSO4 is there, again oxygen is there, of course, sulphur is also added, or calcium carbonate CaCO3, here also oxygen is there. So, oxygen is maximum 46.6%. Sodium cannot remain in free state, you know very well. So, sodium oxide, sodium nitrate, sodium different compounds are there. Potassium, it cannot also remain in free state, you know very well. So this is 2.6% is potassium is there, but it is also in the form of compound having oxygen. Magnesium, same thing, MgO, MgCO3, magnesium carbonate will be there in the ore. Now, lithosphere compounds, what are the things? SiO2, see it is highest 99.07%, Al2O3 it is 99.7%, silica, next is alumina high 15.22%, COO 5.10%, FeO 3.71%, this is combination wise. Na2O sodium oxide 3.71%, magnesium oxide 3. So, it has come down like that. Okay. Based on this you can say, please go to the previous slide. Based on this you can say that, see, after oxygen you can see in the next table silica is high 99%, alumina is next high Al2O3. So, here also silica is highest so far solids are concerned, apart from the oxygen which is gas. Alumina is also solid, so it is next high like the previous. So, the next chart also holds good according to this chart. Next please. Lithosphere minerals, what are the minerals which are most common and highest? One of the highest, see, plagioclase feldspar. I was talking about the rock forming minerals. So, these are the rock forming minerals, okay? Quartz, alkali feldspar, plagioclase feldspar, amphiboles of biotites, then magnetite, apatite, these are all rock forming minerals. By volume it has been given in earth's crust. Next please. What is the meaning of lithosphere? Litho means the solid rock. Okay. After certain depth there will be no more soil, there will be no more clay, there will be no more groundwater, and that depth is how much? Around, say, around 700 meters, 800 meters. After that the say after 1000 meters the effect of lithosphere starts. Okay. In India also the deepest mine was, it has been closed now, that is why I am saying was, Bharat Gold Mines Kolar Goldfield, that was the deepest mine. It had gone up to 3000 meters below, and some of the South African mines, that too also gold mines are there, that has gone up to 4000 meters, that means 4 kilometer below. The Bharat Gold Mine Kolar Goldfield was situated in, it is still the area situated in Kolar area of the Karnataka, okay, Karnataka state. Weathering agents, see, there are few weathering agents, wind, air, it has fourfold effects: abrasion and erosion, oxidation and erosion, acidic reaction, erosion, transportation, erosion, and subsequent deposition. Next. Hydro, water is also the weathering agent. Water it has following actions: dissolving as solvent, erosion, it causes erosion, oxidation due to available O2 in air, so erosion, like rusting. How the Fe2O3 forms? You leave the plate, steel plate outside, which is ordinary steel, not the high carbon steel, it will be catching rust. How? Because of water combines with that, water is eating away the steel in combination with oxygen, which is causing the reaction with steel to form Fe2O3. Acidic basic reactions, as I had said, you know that some of the ores are having sulphide. So, sulphides that creates acid, sulphuric acid in the water, in the percolating water, causing the water pollution in the mine area, and that is having weak acid or even basic. In limestone mines the basic property of the water is more. In metal mines where the sulphides are there, like zinc sulphide in Jawhar, then other sulphides, copper, like your Malanjkhand. So, that is chalcopyrite. So, in that case copper ores CuS, that S is causing the formation of SO2 with combination from the oxygen of the air, and it is forming SO2. SO2 combining with water, groundwater, is causing H2SO3, that means sulphurous acid. H2SO3 plus O2 again from the air is making H2SO4. That way the acidic action starts. Deposition, crystallization on the rock, and rock gets dissolved and it is causing weathered. Deposition, crystallization, it is also causing crystallization to form the ore mineral. Transportation by water, weathering agents, it is forming sedimentary rocks. Okay. Submergence under the pressure, submergence means it is getting sunk, where in the low line area, low line, that means where the rivers are there or nala streams are there. So, the submergence of the deposited rock due to weathering, if it goes down below and above that another formation takes place, geologically that comes under the pressure to get compacted and it is forming the sedimentary rock. Next please. Heat temperature, it is also very important weathering agent. What happens when the rocks are getting heated up in summer season or where extreme heat is there near any volcanic eruption or any other places, even general rocks also where volcano is not there, it is expanding under the heat, and when there is a cloud coming on the top and rainfall is there, or sudden there is a stream changing of the river courses or natural drainage systems, that water is coming on the rock and it is causing the cracks. Through the cracks, the acidic water, as I told in the previous class B, the type B watery and acidic weathering agents. So, that is going inside under the high temperature, because that water is also having some temperature, earth water it is there, it is not a normal water. So, that water is going down and down and down through the cracks and causing the weathering of the rocks. That is why weathering is limited up to the top few meters from the surface, say maximum up to 20 meters normally. After that there is no effect of weathering. Physical weathering, as I showed, I have already told you, wind, water and thermal sources. Chemical weathering, as I told you, the geothermal, the acidic water, which I described how it is forming. What is hydrothermal solution? The hydrothermal solution is having acidic, may be having acidic property, may be having basic property depending upon its rocks in contact, and water contaminated in that through acid rain, etc. As I said, in coal mines the lot of sulfur is there in coal deposits. So, that sulfur is getting burnt along with coal burning when it is used for thermal power plant, and that sulfur is forming SO2. SO2 in turn with moisture of the cloud and moisture of the earth, it is for moisture of the cloud, when it is evaporating up, SO2 is going up, it is forming with cloud, it is forming H2SO3 sulfurous acid. Along with that, when oxygen is further added in reaction, it is forming H2SO4. So, that is forming the mild sulfuric acid in the cloud, and when it rains down, it is called acid rain. Next please. Biological weathering, what is this? This is basically the natural leaching process. What is leaching process? There are so many bacteria in nature which eats away a particular type of rock or mineral. So, it will be leaving behind the other mineral or other type of rock. There are so many minerals in a rock. So, the bacteria will be only eating away few type of minerals which it is attacking. Left out will be different rock. So, the pores will be there inside the pores will be developed inside the rock, and that is causing the weathering. Similarly, there are vegetation rooting causes physical cracks in the rocks, thus get vulnerable to other weathering agents through which the water percolates down, the hydrothermal solution goes down to weather it further, to make it further weathering process on. So, like that the weathering process goes on, but it normally does not extend below 20 meters of depth. See, this is the forces acting on earth's crust because of volcanic action. See the vent on the top, the heel is there, the rock is there, bottommost black mass is your magma. Okay. The top portion is going like pipe, central pipe, and it is forcing out the lava on the top. When the magma comes out on the surface to spread on the surface, it is called lava. Okay. Not before that, unless it comes out of this earth and spreads on the surface of the earth, it is not called lava. Till then, before that it is called magma. Next, see, this is another type of now that is the lava now, the black portion is lava now. Okay. Next, see, the magmatic eruption causes the formation of so many structural changes inside the earth crust. See, the blue line on the top is see, the topmost is the volcanic cone, that is formed because of volcanic lava only flown outside. Okay. And you can see from the bottom, the red portion is the magma, batholith. Batholith means which is holding the semi plastic and liquid type of rock. Okay. So, that is causing the eruption upward, wherever it is getting the cracks in the upper layer of the rock, and that is flowing out because of the high pressure and temperature. It is forming a hill, that is called volcanic cone. Now, what is silts? Between the two types of layers of rocks, there are some gaps, and this magma gets way into these cracks horizontally. So, that is called silts. Okay. What is called dike then? The dike is, silts are, you can see the silts are horizontal in its formation. It is a horizontal plate, it is not a pipe, which was explained in the first diagram. Okay. Pipe is volcanic pipe, that is different, a crater on the top, then a volcanic cone and crater on the top, that is different thing. But here it is a plate is moving through the cracks, crack like this, and it is moving like a plate, the magma is moving like a plate. If it is not like a pipe through which it will go up, no, it is a crack, and through that magma is going up. So, it is forming the sill horizontally wherever it is getting the way to penetrate, and when it is going up other than horizontal direction, that portion is called dike. These type of formations are very common in coal mines as well as in metal mines both. Next please. The coal seam we will see the dikes. Effect of dikes and sills in mining. Up to 2 meters width on either side of the dike, sill contamination is high. That means, it is another kind of mineral, another kind of material. It is basically impurities which has penetrated into the ore body. So, it will be different in chemical structure. So, it is impurities, it has to be taken out, okay, or it has to be left as a support in the mining throughout its life. So, ore body needs to be rejected in that portion. In coal bed, burnt coal needs to be rejected. When the dike is going in the coal seam, both sides up to 2 meters, 3 meters width, the whole coal is getting burnt. So, 3 meter this side, 3 meter this side, 6 meter coal, burnt coal will be found, that has to be rejected. Leave it as a support to the roof of the coal mines. The zone on either side is burnt, so strata is weak, needing heavy duty support. Leave it as a support only. Why to make support after digging it? Even if you are making a driveway through it for necessity, then because it is a weak portion, put better support, okay, because it is a weak portion. Rejection because of coal is burnt, because of ore body is also burnt. So, it becomes weak at high temperature. Rejection ratio of waste rock versus ore body becomes high because of this dike and sills found. Naturally, these are the wastage rocks, not desirable to be seen in the ore body. So, it will be thrown as a rejects. So, it is in open cast working, the effect can be clearly seen that it is causing overburden more, okay, removal, because it has penetrated the ore body, it is blocking the ore body also. You cannot mine near that because it is impure ore body, more impure ore body. Tectonic forces, dynamism due to floating earth crust plates on core, semi molten part of crust. See, the earth crust is on the top, okay, and it has cooled down. While cooling, it has developed the cracks, okay. While cooling means shrinking, while cooled down, the earth crust got shrunk, and because the area got shrunk of each block, there are cracks developed in between the two plates. Okay. So, now when these two plates are floating on the earth magma or semi molten mantle, so crusts are floating. So, when it is floating, it goes like this, it can go like this, it can go like this, and that is causing the earthquake, and that movement is called the tectonic movement. Sometimes when it is colliding like these two plates, it is giving rise to formation of hills like Himalaya. Himalaya is a formation because of the tectonic forces horizontally working on the bed, and it is going up. Himalaya is still rising every year by 1 inch. Okay. So, this is called tectonic movement. What is tectonic movement then? It is a horizontal force or maybe the vertical relative forces to cause the damages or to cause the changes in the earth crust. Next. Now, what is dip and strike of the bed? It is see, we are coming to faults now. Okay. Fold and faults. So, there is a fault plane which has got the strike and dip. What is strike? This is the anything running a block is shown here, the hatchet portion is showing the thickness of the coal seam. So, its extension, the coal seam extension on the horizontal direction is strike, and its extension below the angle the angle when the coal bed, this is surface and this is the coal bed. So, this angle form is dip. Okay. If this is the thing, this is a seam like this, then this angle form is dip with the horizontal. Okay. Anyhow, you can see the topmost beds are horizontal beds, whereas central is vertical 90 degree dip, and the bottommost dips are less than 90 degree. Okay. Next, unconformity. See, this is a see in the earth crust has been formed because of weathering in different layers, and then compaction because of load. It has gone down by tectonic forces. After sedimentation, it has gone down by tectonic forces. There the huge pressure came on that, and compaction, sedimentary rocks found. Okay. Now, above the sedimentary rocks, again it got tilted because of the tectonic forces. On that, weathering took place, eroding the surface. After that, new formation took place. This formation is different age and this formation is different age. The gap, see, there is no sequence of the geological age adjacent to each other. This is of different age and this is also different age, but it is the gap between the two ages are quite huge, maybe even lakhs of years or maybe even millions of years. Okay. So, this formation gap, then this formation gap, the age difference is millions of years. It is not that after this age has started, after this age has started, no. So, that is unconformity. Next please. This is indicated by fossils available, the different ages of the rocks. Fossils means the living remnants, the living prints, that is called fossils. Okay. Next, see, this is unconformity, younger bed on the top and of course, the bottom inclined beds. These are two different formations. The bottom portion has got formed much earlier, maybe lakhs of years before or million of years before. After that, the top formation has come after million years gap. It is not that the bottom formation has got has been formed million years ago, say 1 million year ago, another on the top it has formed just 1.75 million years ago. No, it is not that quick succession. It is bottom has been formed at least 1 year, maybe 5 million years ago, 10 million years ago, and the top formation has come after it is hardly 1 million year old. So, this is called the unconformity. It cannot be told what is exactly, that is why it cannot be confirmed geologically. Next, these are the types of unconformities. Plane of discontinuity is, see, there is a separate complete, so bottom rock is igneous rock, above that sedimentary rock has been formed. Okay. So, this is completely a disconformity plane, but it is uneven disconformity plane. Okay. Next, what is inliers and outliers? When in the succession the formation takes place in such a way that older rock gets surrounded, if you see the plan, the older rock will be seen at the center and the younger rock will be seen on the concentric circles on the outside. So, that older rock which is at the center, that is called inliers. If that older rock comes outside and the younger rock comes inside, that will be called the outliers. Just remember that where is the older rock position. If the older rock position is at the center inside, it is inliers. If it is outside surrounding the new rock, new formation, then it is the outliers. It is causing what? It is being caused due to folding, then it is also called due to faulting, and it is also caused by folds. What is folds? The bonding of rock strata due to, see, basically it is a fold is a bending, it is bending, fold means it is bending. Okay. The bending of rock strata due to compressional forces acting temporarily tangentially or horizontally toward a common point or plane, like this, common point or plane, okay, from opposite direction is known as folding. Suppose if you take a piece of cardboard which is flexible, if you press it from both sides, what will happen? It will either go up like this or it will go down like this. In both the cases the strata has got folded. So, this one folding is called the anticlinal fold, downward gone fold is called synclinal fold. Next, see, what is axis of fold? It is a plane which is going centrally to the vertex of the fold, the top vertex of the fold or bottom vertex of the fold. The top vertex and bottom vertex of the fold will be called, will be having a plane, vertical plane, or at least a plane which will be dividing the two sides of the fold symmetrically, that is called the axis. Okay. Now, bottom of the fold is called trough in case of synclinal fold, and top of the fold in case of anticlinal fold is called crest. Axial plane you have understood what is that, what is limb of the fold you can understood, you have understood limb, there is with a fold, with single fold there will be two limbs formed, whether it is synclinal or anticlinal fold. Okay. Next, major types of folds. Anticline fold, in that case the older rock gets surrounded from the top, it is not visible from top, whereas the younger rock is visible from top in case of synclinal fold. Okay. Naturally, the younger rock is on the top and the older rock is at the bottom. So, when fold takes place, this kind of situation will be arising. Next please. Effects of fold in mining. Symmetrical occurrence of ore body on either side of the axial plane of folds. On both the sides, when the fold gets weathered, when suppose the vertex of the, when the apex of the fold is removed, what will happen? The ore body will, see, this is the fold, when this portion is chopped off because of weathering. So, the ore body will be going running like this and central portion will be there. So, it will be symmetrically seen. Okay. Next, hilly zone mining is encountered, particularly folds, the folded portions are upside. Okay. Or, and even if it is suppose inclinal fold, the valley mining will be encountered. There are benches level needs to be changed either in upper or lower side. That means, the ore body will be moving up. Suppose if you make mining like this, the ore body will be moving up more you advance. So, the level of the benches for ore body will be changing. The bottom portion may enter to the west, the top portion level will be changing, the level number nomenclature will be changing. Next, strip effect of folds, okay, effects of fold, steep drivage, raise or winch in underground mining because of this ore body, the steep drivage like winches and raises from bottom and winches from the top. This is a way it is made. If the vertical passage is made from one level to other level from top, it is called winch. From bottom, if it is raised from bottom level to top level, it is called raise. At the crest, in case of anticlinal fold and through bottom of synclinal folds, bottom means trough, cracks develop in rock bends. Any rock bend which is taking place at the on the crest or at the bottom where trough is there, the crack will be developed because of tensile force. Tensile force, any say any thermocouple, if you bend it, what happens? It develops crack and breaks, is it not? So, even if a clay sheet, clay means the soil, if it is a bed like this, if you turn it in its plastic condition, the crack develops at the vertex, I mean to say wherever the apex is there or synclinal wherever the trough is there, is it not? So, that crack through which the weathering agents enter and there will be heavy weathering of the mineral body. Next please. It happens more in surface mining. What is fault? Fault in geology, a planar, or planar means it is a plane, gently curved fracture in the rock of earth's crust where compressional or tensional or shearing forces cause relative displacement of the rocks. Okay. The bed is there, it has got broken and set apart, that is called fault. Next, faults are well defined cracks along which the rock masses on either side have relative displacements. The attitude of the faults are defined in their terms of strike and dip, as I had told you in the dip and strike directions of the bed. Faults description: foot wall and hanging wall. See, foot wall means which is supporting and hanging wall means which is resting. Okay. Then fault scraps, it is a relative displacements on either side of the fault. Okay. Fault line scrap, it can be well defined through the diagrams next. Then see, this is diagram. See, the fault has taken place like this. Suppose the tectonic forces acted like this. So, it has moved along the strike direction, whereas if it has moved like this, it has moved along the dip direction. Okay. So, these are the different types of terminologies given here, and you can understand it is nothing difficult by means of the what are the features of a fault, the dimensional features of a fault. Okay. Then what is the reverse fault? If the force has gone up, then there is a reverse fault. If the force has pushed down the rock like this from the top to bottom, then it is a usual fault. When the force has pushed the rock at the bottom to top, then it is a reverse fault. Next please. Strike, dip, head. What is head? There is a fault plane. Now, whatever fault plane is making with vertical, the angle, vertical angle with the vertical direction, the fault plane, that is called the head, whereas with the horizontal it is making the dip of the fault plane. Okay. Dip angle. Throw and heave. Next, stratigraphic throw, what is net slip, you can go, these all will be understood through the descriptions. It is nothing so geometrically it can be understood. Okay. Next, hanging wall, what is foot wall? Hanging wall is resting on the foot wall, you can see here. Now, phi is the head. Okay. And theta is the dip angle, theta is the dip angle, because it is made with the horizontal, the fault plane has made with the horizontal, and phi is the 90 degree minus theta, that means it has made with the vertical. So, it is the head. Next, fault scrap, AB is the throw of the fault, vertical throw. Okay. BC is called the horizontal displacement is called the head, sorry, heavy, heave. Okay. That is called heave. Next, See, this is the fault, up thrown side and this is down thrown side. So, AB equals to throw equals to DE, you can see here AB clearly, that is then BC heave, okay, equals to EF. So, this is all geometrically it can be understood. Next please. This is the left side is the strike fault taken along the strike direction, right is the dip slip fault along the dip direction, and what are the different parameters, it can be seen here by red mark given by me, it has been shown to you very clearly, nothing difficult to understand. Next please. What is the effect of faults in mining? Sudden disappearance of ore body at the level of drift and drives, suddenly you will find no ore. Water percolation, because it is a crack area. So, water will percolate through that very heavily, and sometimes it causes lot of inconvenience in mining to make the drive through this. Making raised winch in the metal mining and drift in coal mining from, suppose a fault has taken place, the coal body is like this and it has suddenly gone down like this. So, there will be once you are making the way and mining here, suddenly there will be no coal here, and to search the coal you will take the help of boreholes. So, to make a drift to connect from the upper seam with the lower part of the seam which is broken. So, that is called drift in coal mining, okay, and that is called drivage etcetera in underground metal mining. The vicinity of around fault plane is a disturbed zone. So, it may need extra efforts to strata control and for supporting the entire zone at least by 20 meters on either side. Okay. So, thanks to all of you for listening the lecture patiently. Thank you.